Hey everyone, and welcome back to another deep dive. This time, we're going deep on a concept that's, well, let's just say it's a total linchpin in the world of Java and object-oriented programming.
Yeah, inheritance in Java.
It's one of those things that, if you really get it, it can really unlock a lot of power in your code, make things way more efficient and elegant, and we've got some awesome resources to help us break it down.
Yeah, absolutely. And I think that's what we really want to do here is make sure that by the time you're done listening, you've got a solid handle on inheritance in Java.
You know, what it is, why it matters, how to use it effectively, the whole 9 yards.
Definitely. So let's start with the big picture, like what inheritance is really all about.
All right, so at its heart, inheritance is this mechanism where one class, let's call it the child class, can inherit properties and behaviors from another class, which we usually call the parent class or the superclass.
Right. It's like a family thing.
Yeah.
Passing traits down the line.
And in Java, we make this happen with a special keyword, extends.
So you might say, okay, we have a class called animal, and animal can do like basic animal things, right?
Yeah.
It can eat.
Can sleep.
Exactly. And then you might say, well, I want to create a class called dog, but I don't want to have to redefine all those basic animal things all over again.
Right.
So what you do is you say dog extends animal.
And boom, just like that, the dog class automatically gets all those abilities from the animal class.
Right. It inherits those, fundamental characteristics.
And it can still have its own unique stuff, too.
Absolutely. Like barking,
It wags, all the good doggy things.
Exactly. So in this setup, your dog can both eat like an animal because it inherited that ability, and it can also bark, which is its own special thing.
That's a great, super clear illustration of the basic idea.
So let's talk about why this is so incredibly powerful.
Yeah, this isn't just some cool little trick, right? This is considered one of the 4 foundational pillars of object-oriented programming, or OOP.
Oh, absolutely. And we've talked about those before, encapsulation, polymorphism, and abstraction.
They all work together to create these robust and well-structured programs.
And really grasping inheritance is it's a huge step toward mastering OOP principles as a whole.
So when we talk about the benefits, why should developers even care about this? One of the first things that jumps out is this idea of reusability.
Reusability is, it's huge, right? You don't want to be writing the same code over and over again.
If you're building an application, say you're working on a system that deals with a whole bunch of different vehicles. You've got cars and trucks and motorcycles.
Right, they all share some common characteristics.
They've all got wheels, they've got an engine,
And instead of having to code those things separately for every single vehicle type, you can just create a base class, like a vehicle class. Define all those common attributes there, and then each specific type, like car, truck, motorcycle, they could just inherit those from the vehicle class.
So clean.
Super clean and efficient.
And, as you mentioned, it's not just about saving keystrokes. It's also about making your code way easier to manage and maintain in the long run.
Exactly. Think about it. If you need to make a change to how fuel consumption is calculated for all vehicles.
You don't want to have to go and update every single class separately.
No, you just go to your base vehicle class, make the change there, and boom.
It cascades down to all those child classes that inherited from it.
Super powerful for maintainability. And it helps avoid introducing inconsistencies or errors across your code.
It's like having a master control panel.
Exactly. And on top of that, inheritance really allows you to create a structure in your code that reflects how we naturally categorize things in the real world.
You've got these broader categories and then more specialized subcategories within them, and your code can mirror that.
Makes it so much more understandable and intuitive.
Now, when we dive into inheritance in Java specifically, there are a few different ways it can be structured.
Right. Java supports a few main types of inheritance.
We've got single inheritance, multi-level inheritance, and hierarchical inheritance.
Let's break those down.
So single inheritance, that's the one we kind of already touched on, right?
Right, it's a straightforward one.
Like our dog extending animal example.
One parent, one child.
One class directly inheriting from another.
Simple and clean.
Then we've got multi-level inheritance, and this is where it starts to get, a little more layered.
Imagine it like a family tree.
Okay.
You've got a class that inherits from another class, which itself inherited from yet another class.
It's like a chain of inheritance.
Exactly like you might have a German Shepherd class that extends dog, and because dog already extends animal, The German Shepherd indirectly inherits from both dog and animal.
So it's getting traits passed down through multiple levels.
That's the idea.
Pretty cool.
And then we have hierarchical inheritance.
This is where you have multiple classes that all branch out from the same parent class.
Right. Like, think back to our animal kingdom. You could have dog, cat, bird, all inheriting directly from that base animal class.
They all share those fundamental animal traits, but then each one adds its own unique flavors.
It's like a branching family trait.
Now, there's something that Java doesn't directly allow, which is multiple inheritance with classes.
Yeah, this is important.
Why is that?
Well, it comes down to this issue, and developers will know what I'm talking about, the dreaded diamond problem.
The diamond problem.
Yeah, imagine you have two parent classes, let's say movable and drawable.
Okay.
And both of them have a method with the same name. Let's just say it's called display.
Okay.
Now, if a child class, maybe something like animated shape, tries to inherit from both of those parent classes at the same time, you run into a conflict.
Right, like which display method does it inherit?
Exactly, it creates this ambiguity, and it can really mess things up in terms of how the code actually behaves.
So to avoid that whole headache, Java just says, no, you can only have one direct parent class for your classes.
It keeps things clear and predictable.
But Java does have a mechanism for achieving something similar to multiple inheritance.
Right, interfaces. They let you inherit from multiple types, but that's a whole other fascinating deep dive for another day.
Yeah, we'll have to explore that more in the future.
Definitely a worthwhile topic.
Now let's try to ground this with a real-world example.
Sure.
One of the sources we looked at had this scenario with person, employee, and manager. Can you walk us through that?
Yeah, absolutely. So picture a person class, and this is like your most basic entity, right?
Uh-huh.
It might have attributes like name, maybe age,
Okay.
and then a simple action like introduce, where the person just states their name.
Okay, very basic.
Then you have employee and manager.
Uh-huh.
Now, both of those are, in essence, types of person.
Right. They're just more specialized.
Exactly. So it makes perfect sense for them to inherit those basic person characteristics.
So the employee class, which might have additional properties like employee ID and, methods related to their specific tasks.
Mm-hmm.
And then the manager class, maybe with properties like team size and methods for managing a team, they both automatically get that name and introduce functionality from the person class.
Just by saying, employee extends person, manager extends person.
That's so elegant.
Right. You only have to define that logic once
Yeah.
in that parent class, and it just cascades down. It's so much cleaner than writing the same code in multiple places.
And it mirrors how, real-world organizations are often structured.
Absolutely. You have those shared fundamental attributes at a higher level.
And then more specialized roles and responsibilities as you move down the hierarchy.
Yeah, it's a great example of inheritance in action.
So we've talked about reusability, but what are some of the other big reasons why inheritance is such a crucial concept in Java development?
Well, if we step back a bit, inheritance really leads to cleaner, more well-organized code overall.
Okay.
Because you're avoiding redundancy.
Yeah.
You're naturally making your code base smaller, easier to read, simpler to understand.
It's more streamlined.
And the hierarchical structure that you get with inheritance, it just makes the code more intuitive, Like it reflects those real-world relationships that we're familiar with.
And then when you think about large-scale applications that need to be able to grow and evolve over time, inheritance is huge for scalability.
Yeah, you can easily extend your code base without having to reinvent the wheel every time.
Exactly. Like say you want to add a new type of employee to your system, maybe a senior manager.
Mm-hmm.
You can just create that senior manager class, have it inherit from manager, and boom, it automatically gets all those existing management functionalities, and then you just add on what's specific to a senior manager.
It's such a smooth and efficient way to build upon what you already have.
And it minimizes the chances of introducing bugs or breaking existing functionality.
Now, one of the sources we looked at even cited a stat from a JetBrains developer survey,
Oh yeah.
saying that over 90% of Java developers use inheritance in their enterprise applications.
That's a pretty huge number, which really underscores how essential it is in real-world software development.
It's not just some theoretical concept, it's a practical tool that's used all the time.
It's like a workhorse for managing complexity in large-scale systems.
Absolutely. Now, with all that said, it's important to remember that, like any powerful tool, inheritance can be misused.
Right. There are some pitfalls to watch out for.
Definitely. And one of the big ones is creating these super deep inheritance chains.
Like where you have classes, inheriting from classes, inheriting from classes, and so on.
Yeah, that can quickly get out of hand.
It becomes hard to understand, hard to debug, hard to maintain.
It's like trying to, I don't know, trace a rumor back to its original source after it's been passed through like 10 people.
Yeah, or like a game of telephone.
Exactly. By the end, the message is totally garbled.
So the more levels of inheritance you have, the more tangled and complex your code base can become.
And a change in a superclass way up the chain can have these like ripple effects down to its subclasses that are really difficult to predict.
Makes it hard to reason about your code. Hard to figure out where a particular behavior is even coming from.
Totally. Another crucial pitfall, and this one's more conceptual, is violating the ISA relationship.
Can you explain that ISA principle a bit more?
Sure. So the fundamental idea behind inheritance is that a subclass should truly be a specialized type of its superclass.
Okay.
So, like we said, a dog ISA type of animal, an employee ISA type of person.
Right.
But just because two classes might share some similar methods or properties, it doesn't mean they should be linked by inheritance.
Interesting.
Like you could have a car and a bicycle, and they both have a concept of speed, right?
Uh-huh.
But that doesn't mean a bicycle should inherit from car or vice versa.
I see your point.
The core relationship isn't really a true ISA relationship.
They're both vehicles in a broader sense, but a bicycle isn't a specialized type of car.
Exactly. If you misuse inheritance like that, it leads to a class hierarchy that's kind of illogical. It can make your code a lot harder to understand and work with.
One of the sources we looked at even offered a pro tip. They said, favor composition over inheritance. What's that all about?
Composition is kind of a different approach to achieving, code reuse and flexibility.
Okay.
So instead of inheriting functionality, a class achieves it by holding instances of other classes.
So it's more like a has-a relationship rather than an ISA relationship.
Exactly.
So like in our car and bicycle example, instead of trying to force an inheritance relationship, both of them could have, say, a speedometer object.
Right, they both have a mechanism for speed.
And this can lead to designs that are more flexible, less tightly coupled.
Especially when that ISA relationship isn't a really strong fit.
Makes a lot of sense. So to really nail inheritance and use it effectively, what are some best practices or tips that we should keep in mind?
Okay, well, one thing that all the resources really emphasize is keeping your superclasses as generic as possible.
Okay.
They should primarily contain the logic and attributes that are truly shared by all their subclasses.
So really essential stuff.
Exactly. That helps to keep them focused, manageable, less likely to change in ways that could break things downstream.
Like a solid foundation.
Exactly. And then another key tool is the super keyword.
Okay, what does that do?
So this allows a subclass to explicitly access and call methods from its direct parent class.
Uh-huh.
Which is super useful when you want to, extend or modify the behavior of a parent class method in the subclass.
So you're not starting from scratch, you're building upon what's already there.
Precisely, it promotes that code reuse and efficiency that we talked about.
The sources also made a point of highlighting the importance of access modifiers, private, protected, public.
Yeah, those are absolutely crucial.
Why are they so important in the context of inheritance?
Well, they basically control what gets inherited and what stays hidden within a class.
Okay.
So private members of a superclass, those aren't inherited at all.
They're totally off limits to subclasses.
Right, then you have protected members.
Uh-huh.
Those are accessible within the superclass and its subclasses.
So it's like a more limited scope of access?
Exactly. And then public members, those are open to everyone.
Accessible from anywhere.
Right, so using these modifiers carefully is super important for maintaining the integrity of your code and ensuring that things behave the way you expect them to.
It's all about setting those boundaries and controlling the flow of information.
Definitely. And last but not least, clear documentation is a huge help, especially when you're working on a team.
So everyone's on the same page about how the classes are related and what inherits from what.
Good documentation can save a lot of headaches down the line.
All right, time for a quick knowledge check to see if we've been paying attention.
Let's do it.
All right, so our sources posed this question. If Class B extends Class A, and Class A has a method called run, can Class B call it?
Okay, so the answer is yes,
Yeah.
but there's a catch.
There's always a catch.
The run method in Class A has to be declared as either public or protected.
Right.
If it's private, then Class B doesn't even know it exists, so it can't call it.
So it all comes back to those access modifiers, right?
Exactly. They control what's visible and what's not in an inheritance relationship.
So to wrap this all up, this deep dive into Java inheritance has really shown us that it's not just some fancy trick.
No, it's a fundamental tool.
For writing efficient, well-organized, scalable code,
It's about leveraging existing structures and relationships instead of reinventing the wheel every time.
and by really understanding the principles, the different types of inheritance, the benefits, and even the pitfalls.
You can make inheritance a real asset in your Java projects.
So I want to leave our listeners with something to ponder.
Sure.
We've talked a lot about how inheritance can be used to model these ISA relationships that we see in the real world.
Right.
What are some concrete examples, in different domains or industries where inheritance would be a super effective approach?
It's a great question to consider.
And conversely, what are some situations where that composition over inheritance principle that we talked about might actually be the better choice?
Yeah, food for thought.
Thanks for taking this deep dive into Java inheritance with us.
Absolutely.
We hope it's given you a solid understanding and maybe sparked some new ideas.
And thanks all of you for joining us on another episode of The Deep Dive.
Keep exploring and keep those questions coming.